Assalamualaikum. Chapter 6 Chemical Equilibrium. The first is Dynamic Equilibrium, 6.2 Equilibrium Constant, and 6.3 is Le Chatelier Principle. For 6.1, at the end of the lesson, students should be able to explain the reversible reactions, dynamic equilibriums, and law of mass of action. Second is state the characteristic of system in equilibrium. And the last is explain the chain of concentrations, reactant, and product based on the curve of the graph of concentrations against the time for a reversible reactions. Before we go to further study, we need to know in the thermodynamic have the three system. The first in open system, the second is enclosed system, and one more is the isolated system. And analogy is the dynamic equilibrium only occur in the closed system. Have the two chemical reaction. The first is the one direction or one-way reaction. The most chemical reaction proceed to completion. The reaction continues until one of the reactant completely used up and reaction stop. So reaction take place in the one direction. Use one arrow. The example is CH4 methane react with the chlorine under UV and use a one arrow, and the product is chloromethane and HCl. Type of the reaction is reversible reaction. The reversible reaction is, however, many other reactions do not proceed to completion. Not all the reactants are changed to the product because the product can dissociate to form the reactant again. Reactant take place in the both direction. Example, the reaction A to B, reactant A, and the product. We use the example A and B, the reaction of A and B. The proceed left to right, reactant left to the right, is called the forward reaction, and the reaction from the right to the left called the reverse reaction. Chemical reaction which take place in the both forward and reverse direction are called the reversible reactions. And we use the double-headed arrow, to indicate the reversible reaction. The example of the reversible reaction, hydrogen react with the iodine gas, and they use the double-headed arrow. The product is 2Hi and the gas. Use the same example. So in the reversible reaction, initially the reaction proceeds toward the formation of the Hi. Is a reactant react to the Hi. And then, as soon as some product molecule form Hi, the reversible process begin to take place. Reactant molecule hydrogen and iodine are formed when dissociation of the product molecule. So the dissociation of the product molecule is 2Hi to H2 and I. H2 and I combine to form the Hi at the same time as the Hi decompose to form hydrogen and iodine. Consider the following reversible reaction. The concentration times graph for the reaction A and B. This one is the concentration and it's a time. From the graph, first, concentration the A decrease with the time, and the concentration B increase with the time. After the time T1, here, concentration A and concentration B remain constant. The concentration is remain constant. Take note, as a reaction proceeds, then the rate of the forward A to B, rate of the forward reaction decrease, and the rate of the reverse reaction is increased. The rate of the reverse B to A is increased. When the rate of the forward is equal or same with the rate of the reverse reaction, concentration A and B remain constant. This here concentration and A and B remain constant. At this point, system is said to be in chemical equilibrium. After the T1, the reaction continues indefinitely even after equilibrium has been attained. The equilibrium is dynamic equilibrium. This is we call the dynamic equilibrium. What is the dynamic equilibrium? Equilibrium that exists in the closed system when the rate of the forward is equal to the rate of the reverse reaction, and then the concentration of the reactant and the product remain constant over the time. The example refer to the graph, the conclusion rate of forward and the equal rate of the reverse. That is the dynamic. Remember that for the reaction, example, for the reaction N2O4 produce 2NO2. At the equilibrium, the word is at the equilibrium, rate of the forward reaction N2O4 to NO2 is equal the rate of the reverse reaction. N2O4 concentration N2O4 and concentration NO2 concentration of reactant or concentration of product remain constant, but concentration N2O4 not equal the concentration of NO2. Please remind. Characteristic of system in dynamic equilibrium. Please remember, equilibrium can only occur in the closed system. The first is the concentration of the reactant and the product are constant over the times. The second is rate of the forward is equal reverse reactions rates. And the third is the reaction quotient Q is equal the equilibrium constant. So we explain in the next slide what is the equilibrium constant. The three possible reaction at equilibrium will occur below. Can explain below. First, the reaction start from the NO2. The reaction is start from the NO2. Second is start from the N2O4. Start from the N2O4. And the third is start simultaneously from the NO2 and N2O4. So equilibrium is here after the lines. Even though equilibrium is reached in all cases, the equilibrium concentration NO2 and N2O4 are not the same. Remember, after the equilibrium reached, the concentration N2O4 and concentration of NO2 is not same. If the ratio of the concentration at the equilibrium, concentration of NO2 per concentration of N2O4, refer to the data below, is here. And one more, it use the same ratio but use the coefficient of NO2, and we got the special value is here. Is a constant value. Is a constant value. The ratio of the NO2 per concentration of the N2O4 or product per reactant and use a value of coefficient is a constant. Is a constant, and is a we call K. Is a we call is K. K is known as the equilibrium constant.